Hi students, today we will discuss about one problem on eigenvalues and eigenvectors. I have taken the problem find eigenvalues and eigenvectors for the matrix A is equal to 1, minus 1, 2, 4 and also find determinant which equals the product of eigenvalues. So they have given you total 3 questions. Find eigenvalues, find eigenvectors and also find the determinant which equals the product of eigenvalues. So here we have to find eigenvalues. So under solution I am taking the first part, eigenvalues. To find eigenvalues we have one characteristic equation, that is nothing but determinant of A minus lambda I is equal to 0. What is I? I is identity matrix. For 2 cross 2 matrix, the identity matrix is going to be diagonal elements are going to be 1 and the remaining are going to be 0. For 3 cross 3, look at this, diagonal matrix is diagonal entries is 1 and the remaining are going to be 0. So with the help of this I have written here A minus lambda I. What is the value of A which is given here and lambda as it is I. I means for this is 2 cross 2 matrix, hence we have to choose 2 cross 2 identity matrix. So this is a simple matrix subtraction. So we have subtracted 1 minus lambda here, minus 1 0 as it is, 2 as it is, 4 minus lambda, it is going to be 4 minus lambda. So now once I got this, what we have to take next? We have to take determinant of A minus lambda I. Hence we have taken here A determinant of A minus lambda I. So here instead of matrix I have written the determinant symbol. Next take the determinant 1 minus lambda I multiplied by this 4 minus lambda I minus of 2 minus lambda 1. So overall we will get here 4 minus lambda minus 4 lambda plus lambda square plus 2. So here if I take this lambda square minus 5 lambda plus 6 becomes after simplification. So determinant of A minus lambda is equal to lambda square minus 5 lambda plus 6. But what is the characteristic equation? We have to make it equal to 0. So that's why characteristic equation I have considered determinant of A minus lambda is equal to 0. So take this and make it equal to 0. It's a simple quadratic equation. Take this here. We can split this into 2, 3 and 2. So it is if I add minus 3 minus 2 becomes minus 5. If I multiply it becomes plus 6. So here simple common factor you can take it, lambda and lambda minus 3 to lambda minus 3. So one time it is lambda minus 3 and other time it is going to be lambda minus 2 which is equal to 0. So we got lambda is equal to 3 and lambda equal to 2. After finding this quadratic equation we got 2 values. These 2 values are going to be called by the name eigenvalues. So eigenvalues how we got? With the help of this characteristic equation A minus determinant of A minus lambda is equal to 0. Once we find this eigenvalues we will find the second part as eigenvectors. So for eigenvectors I will use the equation A minus lambda I multiplied by x. X is some matrix here is equal to 0. So that x is column matrix which is 2 cross 1. Note here it is just a bracket. It is not a determinant. Remember this. It is not a determinant. It is just a bracket. So here that A minus lambda I that we got from here, just observe here it is just A minus lambda I. This value I will pick over here and I will write not this value, this value. So here that A minus lambda I have written here followed by x. X is nothing but x1 x2 I have written because it is column matrix 2 cross 1 which is equal to 0 0. Now you are having a one doubt here, very important one here, column matrix. Why I have to write 2 cross 1? So here I already have this matrix as 2 cross 2. If I write this as 2 cross 1, now look at here what is going to have. By matrix rules this 2 and this 2 must be same, so that is satisfying. And if here I will be having 2, if here I will be having 1, so it is going to be 2 cross 1 that we have to write here 2 cross 1, that is 2 rows and 1 columns. Here also 2 rows 1 columns. The main thing is these 2 should match and the last 2 will be going to here. Then find the eigenvector. Now we are going to find the eigenvector for 2 values. We are having 2 values. One is lambda 3 and other is lambda 2. So first we will find the eigen value lambda 3. We will find the eigenvector. So now here the same thing, just what you have to do is just substitute lambda is equal to 3 in the above this format. So just substitute. If I substitute lambda equal to 3, it becomes 1 minus 3, that is minus 2. Minus 1 as it is, 2 as it is, 4 minus 3 is 1. So this as it is, this as it is. So here from this we will get two equations, minus 2 into x1 minus 1 into x2. So similarly 2 into x1 and 1 into x2 is equal to 0. So from this any one equation, so I will take first equation, minus 2x1 is equal to, I will push this, it will become x2. So if I take the ratio, very important, x1 divided by x2 is equal to, here you will get coefficient 1 and here you will get, you can just push this to the denominator, you will get 1 divided by minus 2. So eigenvector how I can write is, it is for x1 it is 1 and for x2 it is minus 2. So it is, you can observe x1 it is 1 and x2 it is minus 2. Similarly we can find the eigenvector for when eigenvalue lambda is equal to 2. So when lambda is equal to 2, just substitute the lambda equal to 2 in this, so you'll get this format. So go through the first row, minus x1 minus x2 equal to 0. If I take this, x1 is equal to minus x2, you will get, take the ratio as like here, x1 by x2 is equal to minus 1 by 1. So eigenvector what I will get, minus 1 by 1. So we got two eigenvectors, one eigenvector for one eigenvalue and other eigenvector for either eigenvalue. Like this, number of eigenvectors is going to be totally depending upon the number of eigenvalues. So the last part is you have to find here determinant which equals the product of eigenvalues. So what is the two eigenvalues we got? 3 and 2. If I take the product of 3 and 2, what it becomes? 6. We have to match that 6 with the determinant of the given matrix. This is a given matrix. So take that given matrix, find the determinant of that, you will get 6. And check with the eigenvalues. What is the eigenvalues we got? 3 and 2. So take the 3 and 2 multiplied 6. So 6 is determinant and also 6 is the product of two eigenvalues. So what I can conclude, the product of eigenvalues are equal to the determinant of A. So this is how one simple problem which we solved, which we have found eigenvalues, those are nothing but 3 and 2, eigenvectors, those are nothing but 1 and minus 2, minus 1 and 1, and lastly we have found the determinant which equals the product of eigenvalues. So this is what the problem is all about. So thank you for listening.